Hey everyone, I hope that you're all doing well. In this video, I want to show you a cool fact, which is that the mean is actually a special case of a general sort of principle that we oftentimes are interested in statistics. And the principle is this: we want to find some value. So when we plug that value into some kind of loss function or some kind of deviation function, then square it and then take the sum over the individuals, we find the value that minimizes that sum of squares. And you may be more familiar with that criterion in the case of regression. So we want to find some, say, value of the predictors, beta naught, beta 1, etc., which minimizes the sum of squared residuals, yi minus y hat, where y hat is basically just the prediction, so beta naught plus beta 1 x1, etc. But I want to show you that the mean is actually a simpler case of that, and this might provide some intuition for how that procedure works in a more general setting. So what we're interested in here is saying the following. We want to find some value for some variable y tilde, or some variable y. We want to find some y tilde such that we minimize the following function, L of y here is equal to right? And so we want to first start by taking the derivative of this function. And this might seem a little bit intimidating because there's a summation operator there. And you might wonder, well, how do I do derivatives in the case of a summation operator? But it's actually really simple because a summation operator just tells us to sum. Not too bad. And you might remember that there's a nice derivative rule in the case of sums that you remember hopefully from your scalar calculus, although if you don't, that's totally fine. You can just look up the rule. But what it basically means is that we can just take the derivative of the separate chunks and we don't need to do anything separate. So let's do the following. Let's write out here L prime, and we're going to say question mark equals because we're not actually going to immediately find the derivative. We're just going to write out the function. And so we're going to write out here yi minus y tilde. And y tilde here just means something that you can see this is eventually going to be the mean. I'm hopefully not spoiling the surprise because I told you that from the outset. But we don't want to immediately identify it with the mean because that would be cheating. So we are going to say this first one here, and let's actually replace this with a concrete individual. So y1 minus y tilde, and we can put a 1 here just to indicate that this is the sort of first individual, even though that's already implicit here, but just to make it really clear. And we'll have y, 2 minus y tilde here, squared, and so on. So that's really all that this is telling us to do. And now we can do a couple of things here. So we need to actually use the chain rule here because we've implicitly sort of got two functions. We've got the function that involves the squaring here, and we've also got this function here, basically, right? So this variable term, because remember that in this case, even though y bar, which we'll eventually replace y tilde with, is fixed, here we're considering this to be a function of y tilde. And I should actually write that up here. So this is a function on y tilde. And here's how we would do that. So we pull down the 2 first. That's the outer part of the chain rule. And then we take the derivative of the variable on the inside, y tilde, and that actually just happens to be negative 1 here because implicitly you've got y tilde to the 1. So you pull down the 1. Y tilde to the 0 is 1, pardon me, and so this just becomes 1, except it's got a negative in front of it, so it becomes negative 1. So pretty simple. And then we do the same thing here, and we can say plus 2 times y2 minus y tilde negative 1, etc. And you can immediately see, we want to set this equal to 0, that we can just divide these coefficients in the front, so it technically becomes a negative 2 in front out. So we can divide both sides by negative 2. And what we end up with is the following. And now this becomes pretty simple. So this is clearly just the sum of two things. This is equal to the sum over the yi's minus sum of y tilde n times. And if we do a little bit of rearrangement, I'm not going to bother writing out all the subscript information every time. Now, what is this side here going to be? Well, hopefully you remember that is just equal to what's the total of the variable, right? And by definition, the total of the variable has to be equal to n times the mean. So this is just replaceable with the following. And then on the left-hand side, we are summing over a constant, so that means that this is just equal to n y tilde. And what that means when we strike these through is that y tilde is equal to y bar. And that's the end of the video. Thanks for watching.